Assalamualaikum warahmatullahi wabarakatuh. Today we will present about our project which is Network Automation for Network Address Translation NAT with Netmiko in subject ITT633 Wide Area Network Technology and Service. Alright, before that, let me introduce for my team project. First, Nurhuda binti Zuraidi, Nisrina Shakira binti Saleh, Siti Nur Akila binti Kamaldin, and Nur Farhana binti Muhammad Yusuf. Okay, let's go to introduction. For our project, our aim is to overcome the challenges of manual NAT configuration on multiple routers by leveraging Netmiko by using Python language to automate diverse NAT configurations, types, and streamline network device interaction. Netmiko provides a unified interface for automating network device configuration, supporting a range of devices include the switch, firewall, and routers, thereby simplifying network management. Here, the program statement that come out from this project. First, manual NAT configuration process is notoriously time-consuming, diverting valuable resources and personnel away from more critical network management tasks. Second, manual NAT configuration is inherently error-prone. Increasingly, the risk of network downtime, security breach, and other issues that can have for reaching the consequences. And next, as network expand and become more complex, manual NAT configuration become unsustainable, leading to scalability issues, increased administrative burdens, and higher likelihood of configuration errors. Alright, there are three objectives that come out from this project. First, to facilitate secure remote access by establishing SSH connection with routers using Netmiko's Connect Handler method, ensuring a reliable and encrypted connection. Next, to dynamically apply and deploy customized NAT configuration, supporting both static and dynamic NAT translation, to ensure accurate and efficient mapping of private IP address to public IP address that meet the specific network requirement. And last objective is to gather crucial configuration data from the routers, including IP address, existing NAT translation, and statistic, to guarantee seamless integration with the NAT deployment and prevent potential conflicts. Okay, I will pass to the next presenter, Nisrina Shakira.
There is benefit of automating NAT using a Python. Firstly, it improves the efficiency and consistency and scalability as well as streamline change management process. Secondly, it also mitigating common issues such as human error, scalability limitations, and the importance of systematic NAT policy update. For the scope of our project, firstly, the project goal is to use the Netmiko to automatically configure NAT, pipe, and static NAT. The script will create secure SSH connection to the routers, collect information on the existing setups, and handle any issue that occur. And every action will be tracked for responsibility and troubleshooting through comprehensive logging and documentation. The project will improve the consistency and efficiency of network administration duties by providing a user-friendly interface in addition to resources for regular update and checks. For hardware and software that we use in this project, firstly, for the software, we use Netmiko, Python, VMware Workstation, JNS3, VM, and JNS3, and then we use Windows 11. For the hardware, we use Lenovo Flex 5. The shown is the image is topology with a router 1 that connect to the router ISP external. We have a loopback 1, and also in the internal we have two multi-layer switch for the multi-layer switch, the connect is two PCs, and then multi-layer switch 2 connect to one PC. The outcome and deliverables in our project. Firstly, we get a highly functional automation script. By create detailed Python script that use the Netmiko to automate network device NAT configuration, it verifies that the script are reliable, efficient, and able to handle any difficulties caused by NAT. Second, flexible NAT configuration templates. We provide easily adaptable NAT setup template that can be adjusted to satisfy different network needs, and we ensure there is certain that a variety of network topology and configuration may be handled by this template. Thirdly, integration error handling and comprehensive logging. Integrate efficient error handling procedure into the automation script to identify and address problems that occur during runtime. It includes an effective logging feature to record important data to support script development and troubleshooting. Lastly, comprehensive implementation guide. We provide the complete guidance on the specific procedure involved in putting automated NAT setup in a place. And then we provide the clear directions, suggested best practices, and examples of configuration to ensure the network, devices, and automation script are secure.
Next is method that used for this project, which is SSH configuration and network automation configurations. First, this is basic configuration for ISP router, which is for an outside router named ISP router. For F00 and F10 are shut down since there are no interface connect to them. And for F11, IP address has been assigned for connection to the inside, and loopback has been assigned an IP address. So we move to the next method for SSH configuration. SSH configuration in the internal router is allow SSH connection between the router and internal devices. For username and password, we use the same name from the user PC. Inside the automation code, Netmiko library is import. So next part is for NAT automation configuration. This is the IP address user validation for user to enter the current IP address. And next is command for NAT automation that user need to enter and access list IP address, subnet mask, IP address range, net mask, and net pool name. For next method is for pet automation. So this is the pet automation configuration that user need to select either use pool or overload method. For pet pool, user need to enter IP address, subnet mask, and pool name. Next is static NAT automation. So this is the static NAT automation configuration that allow user to enter inside local and outside global IP address. For last method is for option user to choose either NAT, pet, or static NAT automation. So we are using if-else command interface that user need to enter the number of choice based on the available selection. For example, if user need to configure NAT, so user need to enter number 1.
My name is Nofarhanda binti Muhammad. I'm going to explain to you about the results and analysis. The first one is NAT automation result. According to the figure, the users wants to configure NAT, so they need to select option 1. And then they need to enter the required information, including the host IP addresses and their corresponding subnet mask to create an access list. They must specify the IP address range to be used for NAT, the net mask for the NAT pool, and a name for the pool. After the information is provided, the system will automatically configure NAT on the router and display the message which is NAT configured successfully. When the user select option 4, which is show NAT configuration, they will receive a list of IPNet translations. Then, the first 10 results are displayed, which are obtained by executing the command show IPNet translation on the router, similar to manual configuration. Next figure displays the statistic for IPNet translations, obtained by executing the command show IPNet statistic on the router, similar to manual configuration too. The second one is pet automation results. When users want to configure pet, they need to enter option 2. Then, they are prompted to choose an overload method for pet automation, either pool or interface. If they select the pool method,
The system will use a pool of addresses for pad. Meanwhile, if they choose interface, the system will use the existing topology's internal interface to the ISP router's interface for pad automation. Once the pad automation is successfully configured, the system will output pad configured successfully. When the user selects option 4, there will be presented a list of IPNet translations. The next figure displays the initial 10 results obtained from the command show IPNet translations, similar to how you would manually configure this information on your router. The second results of option 4 is related to IPNet statistics. It's based on the command show IPNet translation also.
Okay, now for the result and analysis. Here is the static NAT configuration. For this type, same as the pad, first choose the option 3 to configure the static NAT. After choose the options, we enter the inside local IP, which is 192.168.1.2. Then after the outside global IP, which is 209.165.200.229, and then press enter. We can see here the static NAT is successfully configured. Okay, then choose the number 4 to see the total active translation on the static NAT. Here we can only see the inside local. This is before ping to the ISP router. And here is the static NAT translation after ping the ISP router. We can see the outside local and outside global IP address. As for the conclusion, this project has successfully showcased the potential of automatic NAT configuration using Netmiko, demonstrating a seamless integration using GNS3 device and highlighting the capabilities of Python-based network automations. The script robust error handling mechanism ensured the user were informed of any issues that occur during configuration mode and command executions. This project have saved time, reduced error, and set the stage for the future network management improvement. It's allow administrators to focus on important tasks and ensure complex networks are reliable and efficient. Thank you. That's all from us.